Hi everybody! So in today's video we're going to be starting to think about how we can interpret the meaning of the derivative in the context of a problem. Now when I say interpret the meaning of the derivative, it means not just what did you find, what was the value, and what was the number, but what would that mean in the context of a real-world question. So the vocabulary we use here and how we structure our writing in order to communicate our ideas is going to be really important. Let's go ahead and start by using kind of a sentence frame to set up how we're going to think through these ideas. So this first prompt right here says the height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h prime are given in a table, and you estimate h prime of 6 from the table to be 5/2. Using correct units, interpret the meaning of h prime of 6 in the context of the problem. Now we're going to kind of set this up as two sentences to communicate two specific ideas. First, we're going to state what we found and what it represents. And in our second sentence, we're going to state what our findings mean in this specific situation. So you want to use vocabulary that's specific to the problem. The way you can organize your thoughts here, and the reason we've given you kind of a framework to use, is that we can organize our thoughts in this method in order to make sure we don't miss anything when we're communicating our ideas. So the first thing we're going to start with is, what is the derivative that we found? Because if we are going to explain what it means, we need to say what we actually found. So in this problem, we actually found h prime of 6. So our first sentence is going to start by saying h prime of 6 represents the rate. And the reason we're going to use the words the rate here is that a derivative is always the rate of change of a function at a single point. So this is basically the definition of what we found. H prime of 6 represents the rate at which the thing that you measured. So to figure out the thing that you measured, we're going to go back to the original problem, which says the height of a tree at time t. So we're going to say h prime of 6 represents the rate at which the height of a tree is changing when, at that specific moment, t equals 6. So we would say t equals 6, and because in this problem it says that time is measured in years, we would say t equals 6 years. So this first sentence is just, what did you actually find? I found h prime of 6, which represents a rate. It's the rate at which the tree is changing at that specific moment in time. And all that this is doing is giving us the definition of a derivative in this specific context. Now we need to say what it means. Now the difference here is that we're not going to just say, I found a rate. We're going to say, what does that rate mean? So now we're going to start by saying, since h prime of 6, this thing that I found, is positive, we could also change that word to negative if we wanted to in order to communicate a different idea. Then the thing that I measured, the height of the tree, is increasing at a rate that I found of 5/2. And here we're going to say the rate, which means we're going to use per because it's going to be a ratio. It's going to be meters per year. So h prime of 6 is always the rate at which the tree is changing and with t equals 6. More specifically, since h prime is positive, the height of the tree is increasing. It's not just changing, it's growing at a rate of 5/2 meters per year. Now, in a real AP question, they're not going to give you this sentence framework to fill in your thoughts. So what would this look like in a real context? You would be given the same prompt, but you would need to generate this entire idea. So you would write h prime of 6 represents the rate at which the thing we measured, so the height of a tree is changing at t equals 6 years. So that first sentence needs to come kind of out of your brain, but it's this framework that we're following up here that's going to allow us to build that sentence. Then we're going to say specifically in this case, since h prime of 6 is positive, the thing that we measured, the height of the tree, is increasing. How fast is it increasing? We're going to say at a rate of 5/2, because that's the number I found, meters per year. Now, one other thing that we need to be really careful about is we're going to try this again, and we're going to pay very close attention to what we're measuring. So let's try this one more time. It says when a store opens, there are 25 pounds of apples on a display. Customers are removing apples from the display at a rate modeled by f of t. So it's really important here to realize that this function is already a rate function. This is the rate at which customers are removing apples. When we take the derivative of that, so where f of t is measured in pounds per hour, so the units here are already pounds per hour, and if we take the derivative of that, we are finding the rate of what is already a rate. So when we interpret the meaning here, we have to be really careful about our wording of the question. We're going to start the same way. What did we find? We found f prime of 6. And what does f prime of 6 represent? It represents the rate at which, and then here's where we need to be really careful. It's the rate at which f of t, which represents the rate that customers are removing apples from a display. So f prime of 6 represents the rate at which the rate that customers are removing apples from a display is changing at t equals 6 hours. Now you'll notice I said the rate at which the rate is changing. And the reason I did that is because we're finding the derivative, the rate, of a function that is already a rate function. Think of this as almost like the second derivative. You're finding the rate of what is already the rate. So f prime of 6 represents the rate at which the rate that customers are removing apples from a display is changing at t equals 6 hours. So what does that mean? Well, since f prime of 6 is, in this case, negative, the rate, the thing that we measured, that customers are removing apples is decreasing. At what speed? At a rate of at a rate of, we don't need to have the negative here because we already used the word decreasing, at 10.012 pounds per hour per hour. Now you might be wondering, why is it pounds per hour again? The original units here were already pounds per hour. when we took the derivative of that, it created a rate of the rate. Or, in other words, it's the second derivative, so it's pounds per hour. What this means is really like if you're measuring how fast people are grabbing apples, the rate at which they're grabbing them is decreasing. So they're not grabbing apples as fast as they were before after 6 hours. Maybe at the beginning of the day the store is really busy and people are grabbing apples really quickly, and then as time goes on the store is less busy and so people are not grabbing apples as quickly. They're still taking them, but they're just not doing that as fast. So the rate at which the rate that customers are removing apples is decreasing. How fast they're doing it is not as fast as it was before. All right, we are going to do a bunch of practice with this because the wording here is really important and can be really tricky. So thank you guys so much for watching the video, and I will see you in class tomorrow for some practice.